Going on now to section 5 of chapter 2, formulas and problem solving. Well, on page 115, they give us these formulas. Some of them you may be familiar with. This is for area. Area equals length times width. This is an interest formula. Interest is equal to the principal times the rate times the time. This is a perimeter of a triangle where you're adding the lengths of the 3 different sides. This is the distance formula. Distance equals rate times time. A volume formula. Volume equals length times width times height. And I see they left out one of the major perimeter formulas. Let me just add that. Perimeter of a rectangle is 2 lengths plus 2 widths. This is for finding Fahrenheit. If you know the Celsius temperature, you take 9/5 of that, add it to 32, and this gives you the Fahrenheit reading. Or you can convert this into its decimal form. 1.8 times the Celsius gives you, and plus 32 gives you the Fahrenheit reading. So, what's the purpose of all this? Well, when we have a formula, it's a direct hint as to how to solve something they're asking about. If you want to know area and you have length and width, works right in there. But if you have area and you have width and you want to find the length, there's where we have to do some manipulating, and that's what we'll be doing as we continue in this section. Going on to example 1, and we're going to use the distance formula. Distance equals rate times time. That in Alaska there is a glacier that is this long. Now, a glacier is a big mass of ice that moves towards the sea. When the edge gets to the sea, it breaks off and forms an iceberg. There you go. So here, this glacier is this long, and every year it moves 400 feet. So its rate per year is 400 feet. Well, they're wondering from the front edge of this, not the one that's going in there now, how long will it take for the glacier that's at this point way in the back to end up in the ocean? Well, since we know the rate is 400, we don't know the time. So what we do here is we divide both sides by 400. This cancels out and I end up with t, and when I do my division, I end up with this many years. So almost 80 years for that. Now, as you may know, to tie this into science, some of these glaciers are melting faster than they're forming, so they're receding, and some of them aren't reaching the sea. But that's for another course. Going on to example 2, here we want to find the length of a garden. Now, this person can buy up 140 feet of fencing for this garden, and the width of the garden must be 30 feet. So what would the length be? Well, again, a picture would be helpful. And the formula that we're interested in is fencing around, so that's going to be perimeter. And you would need to know that. 2 lengths plus 2 widths. Now the width must be 30. And what we don't know is the length. So, filling in our formula, we know our perimeter is 140. We don't know our lengths, but we know our widths are 30. So I could put 30 and 30 as 60, or 2 times 30. And then I go 140 equals 2L plus 60. And I want to isolate the L, so I'm going to subtract 60 from both sides. I get 80 equals 2L. And now I'm going to solve for my L by dividing both sides by 2. I get my length equals 40. And if I add all these up, they add up to 140. In example 3, we're going to be dealing with temperature, in which we have a temperature of 77 degrees Fahrenheit. What would be the Celsius equivalent? Now we could put the 77 right over here, or we could solve for Celsius first. So let's do that. This is something a little extra. I want to solve for the letter C, which we'll be doing a little later in this chapter as well. Now we want to isolate the C, so I'm going to transpose the 32 to the other side. So I now have F. Transposing that, that becomes a negative 32 equals 9/5 C. Using some of the techniques we have over on the right. Now we had said in order to isolate the C by itself when you have a fraction, we can multiply it by its reciprocal. And keep in mind we have to multiply all of this by its reciprocal. So now the 9's cancel out, the 5's cancel out, and we get this special formula, C equals 5/9 times F minus 32. Now we put the 77 where the F is. And do that subtraction. That's going to be 45. Remember, that's over 1. And a real nice thing happens here. 9 goes into there once. 9 goes into there 5 times. So we then have C equals 25. So 25 degrees Celsius is equivalent to 77 degrees Fahrenheit. Now, had you put the 77 over there, it'd be the same thing. You would subtract 32 from both sides, then take the reciprocal. But here I was showing you a technique that you're going to be using later, that we solve for a specific letter in a formula. And we did that. As we go into example 5 and 6, These are related. And here we are looking to solve for a particular letter. Here in the case, we want to solve for L. Here we want to solve for X. And we're going to use these techniques. No fractions, no grouping symbols, no collecting like terms. Basically, we're going to transpose so that we isolate the letter. Well, here there's only the one term. So how do we isolate the L? Well, we do so by dividing out the WH from this side. And if we do it on this side, we do it on this side. So here the W's cancel out, the H's cancel out, and we have then L equals V over WH. Now this is one that we're going to do in chapter 3, our next chapter. This is the slope-intercept form, but they're asking us to solve for the letter X. So here we want to isolate the term that has the X by itself. So we need to get rid of this, and we're going to transpose that. So we get Y minus B, taking it from this side to the other side. Or subtract B, subtract B. Now to isolate the X, we're going to divide both sides by M. And here you use a division bar to group all your numerator terms. Then the M's cancel out, and there's your answer. X equals Y minus B all over M. Now again, when you put this into MathLab, you have that little tool that you're going to click on to activate to put fractions. And keep in mind, fraction bars should be horizontal. Okay, we're going to finish up section 5 with example 7, and this is a friend now, a perimeter. We want to solve for the W. So again, we want to isolate the term that has the W in, and we do that through transposition. P, bring this over to the other side, and now we just divide both sides by 2, and W equals this. Now, if you had placed the 2 under each of these terms, and did it this way, the 2's would actually cancel out here. That would be a modification, but most of the time, this is the one they want right there. Now, believe it or not, we did this earlier, but we'll do it again. We want to transpose the 32. And again, that technique of transposition, just take a term from one side of the equation to the other. We know, in fact, what we're doing is subtracting or adding the additive inverse, and then we get, and we want to use the reciprocal. Put parentheses around it because it applies to everything on this side. And then these all just cancel out, and C is equal to this. You would take your Fahrenheit reading, subtract 32 from it, and then multiply it by 5, divide by 9. Now, a few others that you might come across, I put them up there as extra. Both of these have fractions. So step 1, get rid of fractions. So we're going to multiply this side by a 3, this side by a 3. Here the fractions go away. So I get 3V equals HWL. And I want to solve for the W. So I'm going to divide out the H and the L. So W equals 3V over HL. Now here's the case where I want to find out what that b sub 1 is, and it's in a parenthesis, so a little different than what we've been doing. But first we want to get rid of the fraction. Multiply both sides by 2, so this becomes 2a. Now I want to get the b sub 1 out of the parenthesis. And now I want to isolate the b sub 1 by transposing this. So I get 2a minus h b sub 2 equals h b sub 1. I'm just taking this term, bringing it over to the other side. Remember, I had to clear parentheses. And now I will divide by whatever is with the term I'm looking for. And that's an h. And notice I could put it under 2 and the h's would cancel out here, or just leave it like so. Again, you're going to do practice. Hopefully you're moving right along. The quiz me's, and next thing you'll know, you'll be ready for your test on Chapter 2.